This question is looking at how do you find the concentration of a weak base given its pH value, and you'll find this question in the SciPad on page 278. It's question 4. Okay, the steps are just the same as if we were working out the concentration of a weak acid, with a couple of subtle differences. One of the differences is we will be using a Kb expression since it's a base. When we need to substitute values into the expression, we're going to need the value of Kb, and it may well be that you're provided Ka or Ka, so you'll need to do some manipulation there. I'll show you how to do it. Finally, when they give you the pH value, you're going to need to not just find the hydroniums, but then go on to find the hydroxide concentration so that you can substitute it in and solve. So let's go through this question. The question is asking that you have a solution of methenamine with a pH of 7.99. So there you go, you've got your pH value provided. And they're asking us to calculate the concentration, and they've given us the Ka. Now notice it is the conjugate acid, so this is a Ka. We are dealing with the base, so we're going to need to do a conversion, which we'll do in step 3 or 4. So just to get ourselves settled in and started, I always start with the partial dissociation of the weak base. So this time the proton is going to be accepted on to the methenamine, which will produce your hydroxide ions. So the Kb expression will look like this. You'll get your methammonium ion and hydroxide divided by the methenamine. From there, what we're going to do is make the assumption that the hydroxide concentration is going to be the same as the methammonium ion, which allows us to replace the methammonium ion with a hydroxide since their values are the same, which is where the hydroxide squared comes from. We also rearranged the Kb expression, so it's now subject to the concentration of the methenamine. So this is the equation that we now need to solve. We are going to need our Kb, and we've been given the Ka. So this is where we use the Kw, which is 1 times 10 to the minus 14, that's a constant, the water dissociation, is equal to Ka times Kb. So to rearrange that and find Kb, we'll take the water dissociation, 1 times 10 to the minus 14, and divide by Ka. Substituting the Ka value in, and we'll get our value for Kb. Show you're working, you're going to get marks for all of these steps. Step 4 is to now find firstly the hydronium concentration from the pH. So we've got the pH of 7.99. To find the hydroniums, it's the inverse log of that negative pH value, which gives us our hydroniums. We need to take this one step further because we need the hydroxide concentration. So again, this is the water dissociation equation given on the resource sheet rearranged. So the hydroxides equal the water dissociation divided by hydroniums. When you put those values in, you'll get the hydroxide concentration at 9.77 times 10 to the negative 7. Now you're on the home straight, and all we need to do is substitute these values in. So we've got the hydroxide value, which we're going to be squared. We've got our Kb value, which we place in, and solve to get your final answer. Remember, your final answer should be 3 significant figures with units. I'll see you in the next video.